We were having a beer on the back deck of our lab in Chernobyl, which is not too radioactive. And we were drinking a beer, and the cuckoo was going, cuckoo, 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 and then it went cuckoo, and just sort of, this odd sound, and Anders went, "There's a mutant."
Hi, Tim.
How are you?
Hey guys,
How's it going, Tim?
that's going good.
Yeah, thank you for being here.
My pleasure.
So how did you get interested in studying radiation in the beginning? It's kind of a very unusual thing. I can't imagine that many people do it.
It is not that popular a subject area. You got that right. It's one of those things that it just sort of happened by accident. I'm an evolutionary biologist by training, and I was studying the genetics of adaptation to climate change and behavior and a few other things, and then just by chance somebody gave me a small grant to go visit Ukraine and to check out Chernobyl, and at first I really didn't think it was going to go anywhere. It was it was not the most pleasant place to be.
Right.
So just by chance ended up going and getting some research done, and started off slow, and what happened was kind of interesting. The just by chance, we published our first paper on some birds that we found that showed these kind of strange mutations, and it got a lot of attention. And so we decided, well, let's just keep going back, and we'll go back to the same populations, and we'll see what else we can find. And we kept finding unusual kinds of things in these radioactive areas, and so it just grew into a bigger and bigger program over the years.
Now, when you go there, do you remember the first time you went to Chernobyl did the first place you go to study, was it Chernobyl?
The first radioactive place that I've been to was Chernobyl. It just sort of launched into it. It sort of came as a byproduct of the collapse of the Soviet Union.
Mm-hmm.
After the Soviet Union collapsed, there was some interest in trying to get American businesses and American academics into these former Soviet republics to promote business and an exchange of ideas, and so there was funding to do this, and the idea was to keep all of their nuclear scientists from building bombs.
Right.
And so and to put them to work studying ecology and evolutionary biology, and it was a good idea, it seemed like, at the time.
Now, were you worried the first time you went there? Because there aren't a lot of other places that have this much radiation.
That's when I first went there, the dogma, the popular idea promoted by the International Atomic Energy Agency, which is this UN sort of watchdog that promotes the peaceful use of nuclear energy. Their official take was that the radiation levels were too low to be of much consequence, and that it really wasn't going to be that dangerous a place to be, as long as you stayed away from the reactor and these other high radiation areas. After studying the birds and the insects, and more recently the mammals, the plants, the bacteria, basically we see all sorts of consequences of even these so-called low dose exposures, and so now we're a little bit more worried about spending a lot of time there.
So where did you fly into when you went in the first time?
It was great. It was one of those completely messed up trips. I missed several flights. The connections didn't work. I was supposed to fly from South Carolina to Atlanta to Paris to Kiev, Ukraine, and of course I missed the connection out of Atlanta, so I had to fly to London, and then I had to fly to Schiphol in the Netherlands, and then the connection out of Schiphol to Ukraine didn't fly, and so I ended up having to go back to Paris. Anyway, I ended up getting there the next day.
Okay.
And it was really interesting because I flew in at night, and the city was dark.
Right.
It was just sort of this dim kind of
Now
glow.
you're flying into to Kiev.
Flying into Kiev in 1999,
Right.
and things were really really bad economically
Right.
in Ukraine at the time, and so they could barely afford to turn the lights on.
Right. So how long is the drive from Kiev to Pripyat?
It's when we first started going there was no traffic, and it's about 60 miles, and with a crazy driver, you could get there in just over an hour. These days there's all sorts of traffic. It's heavily congested. Everyone has a car now, and so it's a 2.5 hour drive now.
Now, when you first go, it's like you sort of have a feeling of what you're going to see, but what do you see, and how soon before Pripyat do you start to see like, I wonder if this was a good idea?
That's really one of the sort of counterintuitive observations people make, is that it actually kind of looks normal. So unless you really stop and pay attention and actually count the birds, you might not even notice anything was wrong. There are trees there. It's not this lunar landscape. It's just that there are fewer animals in the radioactive areas. And the other thing people don't realize is that it's not this uniformly radioactive landscape. It's actually kind of like a quilt work with areas of really high radiation, not too far from areas that are completely clean, relatively normal. It was just because of the way the weather was going on during this 10-day event. And so where it's clean, it actually, things are kind of normal. There's lots of animals and plants look normal, but where it's highly radioactive is where they're not doing so well.
Now, how do you know the difference? Do you have a Geiger counter with you?
Yeah, we always carry Geiger counter. The Geiger counter is the best, actually, because it can detect gamma rays, it can detect beta particles, and it can also detect alpha particles, but it's mainly the gamma and the beta that you have to worry about. And there's a fair bit of this beta radiation, which isn't too dangerous unless you sit on it. If you sit on a particle, of spent fuel that's emitting all sorts of beta particles, then that might not be so good for you. And certainly you don't want to ingest it. You don't want to eat it. You don't want to drink it or breathe it.
Now, what shoes are you wearing? Because doesn't it ruin your shoes?
We usually, when we're in a radioactive area, we put on rubber boots. And the rubber boots are good. You can just hose them down, and of course we leave them there. We don't bring any of this stuff back.
Now, do you go, okay, this is high radiation, we're going to stay here for 22 minutes, or like how do you figure how long you'll stay in a place?
That's exactly right. You have to sort of judge how risky a given a sortie into the forest might be, and so in parts of this so-called red forest, this area that was where the forests were killed by the blast of radiation, they're not red anymore, but they in those areas you can get like a year's normal worth of radiation dose in a couple hours.
Mm-hmm.
And so in those areas you want to minimize the time that you spend there, because there really is no way to protect yourself other than not to be there.
Mm-hmm.
That's just the gamma radiation can penetrate anything, just about, and you certainly can't walk around with a couple of inches of lead or anything like that. So
now, do you go through Pripyat and see the town when you're going out there?
We have a couple of our study sites in Pripyat. They're actually on the other side of Pripyat, where it's more agricultural, or was more agricultural. And the town of Pripyat itself is not particularly radioactive. It's not nearly the most contaminated part of the area. And at the moment, because it's kind of like a Disneyland for macabre disaster tourism, it's a little too busy. And, there are tour buses going through this place. It's
Wow.
ridiculous. Yeah, it's just ridiculous. But so we try to stay away from there if we can.
Wait, this is now, but in 1999, that wasn't happening when you first went, no?
No, in fact, I was one of the first tourists, and in 1999, we were on an official government visit where they took us to these same places that they take tourists to now. Back then, in 1999, 20 odd years ago, it was far more radioactive than it is now. So it's
Now, those areas, it's filled with tourists, but how has nature rebounded there? Because you don't have the normal set of things. So in some places you have animals that have achieved a new, it's not like it was before. Like, what is it now?
So it's kind of a mix. So yeah, in these areas where there are no people, there's no hunting, and it's not radioactive or not especially radioactive, you do, there has been an increase in the numbers of some of these animals that would normally have been hunted and to extinction. And, this part of Ukraine used to have a lot of people and mostly farmers, and they would shoot anything that moved. And so yeah, without people in this 30-mile exclusion zone, in the clean areas, the areas without radioactivity, the numbers of deer, the number of moose, the number of they even have some wolves there now, which they had never had before. We have cameras set up all throughout the zone, and so we get a pretty good idea of approximately how many there are of these lynx, and even there's even a bear that snuck in from Belarus, has walked through the zone a couple of times. Only one, but still, it's because people are missing, and there's no hunting, and so they come back.
So, I mean, the forest there has rebounded in a very unusual way. Yeah. Even in and of itself, just where you see lack of people, you see nature coming back. Yeah.
It's absolutely true that there are things living there. What's interesting though is that if you look at their DNA, if you look at the structure of their DNA, you see damage. There are mutations associated with this. And if right now we're doing a study of dogs that are living kind of wild in the area, and looking at their DNA, and one thing that we've seen is that they don't live as long as they probably would normally, and we don't know how much of that's because of genetic damage. We know for the birds and for the mice and for some of the insects and for some of the plants that the genetic damage has led to shorter lives and lower reproductive ability, and increased rates of tumors, and a number of other kind of sort of standard radiation effects. So it's so there's life there. It has come back, but the quality of life may not be that great for these organisms. And I think from a human perspective, you certainly wouldn't want to put a daycare center in there, right?
Yeah. Now there are people living in the exclusion zone. Yeah.
So that there used to be more, and right after the accident, 5 to 10 years after the accident, quite a number of the old folks who had been living there were permitted to return, to resettle, as they called it, and they didn't allow them to go back to radioactive areas. But like I mentioned before, vast parts of the zone are excuse me, relatively clean. And so they let people, the old folks, come back to their homes where they were born in many cases. And so for a while, there were 400, 500, 600 people living inside the zone, tolerated.
Mhm.
But most of them have died over the intervening 30 plus years now. And so there are very few folks that are from that original cohort that are still living. There are a few people that have snuck into the zone, younger folks that have snuck in, and they're doing their stalker thing. I don't know if you've seen that, but
What's that? I don't
What
know
is
that.
that? What is that?
I don't know much about it, but there was this computer game called Stalker, where you would shoot up all these mutants in Chernobyl and Pripyat, and it was very popular with young men in Europe, and so many of these early tourists were actually guys who had been playing this game on the computer, who wanted to come see what it really looked like to
Right.
recreate their game, and and some of them sneak off and go camping in the zone to get fully immersed.
Yeah.
It's a very strange thing.
Now the tanks in the original reactor, they have these giant fish in them. Now, are the fish size, is that something related to the radiation, or is that just because there's no humans?
That it's actually because they're Wels catfish, and Wels catfish regularly grow to 600, 700, 800 pounds in other parts of Europe, and they just get so darn big. People don't generally try to catch them. They're big enough to eat ducks and
Right.
Wait, they eat ducks? They eat ducks?
Apparently so. I've never seen one do it, but
they're huge, right? You see these things and it's like, wow, what is going on here?
Yeah, 7, 8, 9 feet long monsters. But they, in fact, they there was a TV show that tried to film them. Unfortunately, they've since over the course of the last 5 years now, they've lowered the cooling pond water level. I think it's almost dry now, and the cooling channel is virtually dry, and so these large giant catfish have disappeared. They were only large because they were of this species that normally gets large, and in fact sometimes they put these kinds of catfish near nuclear power plants cooling ponds because the warmer water helps them grow quicker and larger, but nothing to do with the radiation.
We're both fighting for the questions. Jesse's been wanting to talk to you for forever on this subject matter. He's obsessed. I had a question about the cuckoo, like what you learned about the cuckoo bird.
Oh, the cuckoos. I wish I had that slide brought up here. I could play it for you. What I like to tell people is that every time we go to Chernobyl, we turn over another rock and we find something interesting that's clearly the result of radiation. And a few years ago, my partner in research, Anders Moller, he's a Danish fellow who lives in France, and he pointed out to me one night as we were having a beer on the back deck of our lab in Chernobyl, which is not too radioactive. We were drinking a beer, and the cuckoo was going, cuckoo, 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 and then it went cuckoo, and just sort of, this odd sound, and Anders went, "There's a mutant," and so he started counting the numbers of cuckoos in the song of the cuckoo bird, and he also started recording the number of these sort of aberrant calls, these strange calls, and it was perfectly related to how radioactive the area was, and given that in this species the song is mostly genetically determined, this strange calling song probably reflects, again, genetic damage to the individuals living in these more radioactive areas. But we've since looked at cuckoos all around the world, and it turns out that the call of the cuckoo is actually a great little bio-indicator of environmental quality.
Wow.
And it's really interesting. So Chernobyl was our first insight into cuckoos as a biomarker.
Now, in the years that you've gone there, has some areas become less radioactive? Like, I mean, we sort of think these things are going to be radioactive forever, but is there some way that the environment can repair itself or bury the radioactivity?
Yeah. Like, where does it go? I had the same question. Where does it go?
So, the thing about radioactivity is that there's nowhere to put it no, the only way it disappears really is that it will decay.
But that's like I mean, how many years does that take?
Every isotope is different. So for, the two dominant isotopes in Chernobyl, cesium-137 and strontium-90, they're called, they both have radioactive half-lives of about 30 years, 29 and 30 years.
Oh,
So every 29, 30 years, half of it disappears by itself. And so the idea is that with 10 half-lives, it'll be completely gone. And
right.
so it's like 300 years. But, in 100 years, most of it will be gone. But the plutonium, there's a significant amount of plutonium-239, which has a half-life of like 24,000 years. And, and there's some uranium isotopes, radioactive uranium isotopes that have even longer half-lives. And so in the most radioactive areas, it's going to be like that for a long time. Now, some of it, the cesium does move around a little bit. It's the plants move it around. The fungi will take it up and it'll get carried off with a wild boar that eats the mushroom, for instance, or that kind of thing. So the birds will feed on berries that are high in cesium, and they'll carry it and they'll poop it out in some other place, and where the bird dies, they'll dump a little bit of cesium somewhere else, and that's a significant amount of radioactivity that gets moved around. But for the most part, it stays in Chernobyl.
Now, do mushrooms, do they take it, do they process it? I saw things saying that they thought they could use mushrooms to do that.
So what for some interesting reason, the mushrooms the cesium it's an analog of an essential nutrient for plants and mushrooms, and so these fungi will take it up and concentrate it. And not all species do this. Not all species of fungi do it, but some can concentrate it quite heavily. And so the so the critters, the animals that like to eat mushrooms, like wild pigs, for instance, they will often get a big dose of this radioactivity via the cesium in the mushrooms. So in parts of Germany, for instance, the wild boar that the hunters hunt are still inedible because of cesium from Chernobyl. And the same is true in Fukushima, Japan, where most of the wild pigs are still too radioactive to be consumed.
They travel out though. I mean, are they worried about that they can sort of ingest the radioactivity and then move out, and people wouldn't know, right? They wouldn't have the knowledge base to know, like, okay, and they're eating radioactive pig.
Yeah, well, I think everyone knows, that mushrooms and things that eat mushrooms, like pigs, anywhere near Chernobyl or Fukushima, are likely to be contaminated. This is pretty well known. Some people don't care. Same reason some people don't wear masks in public.
Yeah.
And so, yeah, they don't care. So
they think they can get a great deal on some property out by Chernobyl.
Oh yeah, it's real cheap these days.
Is it ever gonna, I mean, do you, when you're there, and you've been going there for a really long time, but do you always feel the sense of, this is one of our great tragedies in the world? I mean, does it feel like a heavy thing that when you go there, or are you just there doing your work? And
it's a bit of both. You have to stop and reflect every now and then again about why it is you're doing what you're doing, and why you're putting yourself at risk doing this kind of work. And the answer is that there's a lot to be discovered, a lot to be known, and it's potentially of importance, given that there's likely to be more accidents of this sort in the future. Every nuclear power plant on the planet is as a potential source of major radioactivity. Every cooling pond has 10 Chernobyls worth of radioactivity. If it were somehow to be released in some way. And so this hazard is there around us everywhere, and so you do have to reflect upon that. But of course, I'm a scientist, and most of what I do is driven by curiosity and an interest in discovery, and so you try not to think about the hazardous part of this.
Does the place feel haunted? Do you go back to a coffee shop you go to every single time when you go to Fukushima on the edge of Chernobyl? Is there like one restaurant you go to hang out that you see the same people with all the time? And do they, what are they like?
It's interesting. There is this one restaurant, which is it's a hotel restaurant in the town of Chernobyl. And there's not many of us who go back to do research there year after year after year, but there's a handful of us, and so you get to see them, you get to know them, and yeah, it's mostly it's about just getting in and getting out as quick as possible. It's radiation isn't the only hazard in this area, so there's also food poisoning to worry about.
The food at the restaurant is as bad as the radiation.
At the risk of insulting somebody, I have to say that it's one of the things that keeps me away.
Now, where did the radiation in Hiroshima go? Because it's like Hiroshima's a city now, but it's like, what do they do? Just take it all and throw it to the dump, and
So that's a really good point, and it's one that people don't completely understand. So the bomb that the bombs that were dropped on Nagasaki and Hiroshima had, I think one of them, I forget which was which, one of them had 12 pounds or 12 kilos of radioactive uranium, and the other had 60 pounds of radioactive plutonium. And it exploded all at once, released a vast amount of energy, and incinerated, a few 100,000 people lost their lives as a result of that. But the fallout, the leftover, the unspent component of that radioactivity was really minimal because it wasn't all that much to begin with. Chernobyl, there were literally thousands and thousands of tons of uranium and plutonium that were released into the atmosphere and spread. So far more radioactivity released as a result of Chernobyl and Fukushima into the atmosphere than the bombs in Nagasaki and Hiroshima. Now, collectively, the U.S., the United Kingdom, France, and a few other countries have detonated over 2,000 atomic bombs over the years, and over 500 of them were detonated in the atmosphere. And collectively, those bombs released enormous quantities, probably 100 times more radioactivity to the environment than Chernobyl did, but it was spread throughout mostly the northern hemisphere, and so if you were in places sort of downwind of these atomic bomb tests, then you may have been exposed mostly in the 50s and 60s, and there's some concerns for that as well.
Now, those bombs, a lot of them were on the atolls, yeah.
There were 67 of them were in the Marshall Islands. And but quite a number of them, I can't give you an exact number. There were quite a number detonated in Nevada, for instance, and some of this fallout actually significantly contaminated mostly the central part Midwest of the U.S.
Now when in Russia they sank some of these nuclear subs when they would get to the end of their age, their time, they just dump them in the sea. What happened to all that radiation? Is it all still blowing around in there somewhere?
So most of it's still locked up in the subs, as far as I know. I'm not an expert on that, but I have been following some of that recently, and there's certainly an interest in retrieving some of these submarines so that they can properly remediate them and put them into storage someplace so that they don't contaminate the oceans. But yeah, it's a huge problem. All of this spent fuel from all these reactors, hundreds, over 600 nuclear reactors, have been operating for most of them for 20, 30, 40 years, and they've all been generating tons and tons and tons, millions of tons of spent fuel, which is more radioactive than the fuel that was actually put into the reactor to begin with. And so, yeah, no, it's a huge problem.
So, you've been studying at Chernobyl for a very long time, and then you're watching on your TV these images of Fukushima, the storm, coming in, and the terrible thing that happens there. And where does your mind go? Does it go to like, well, look, we got to get in there and take a baseline and understand what's going to happen? Because now you're going to start the study all over again in a fresh place, new problems. You don't know where the radiation is. Like, how do you start to, what's the first step?
Yeah, the first step was, how the heck do I get into Japan to start working on this? And in April, the end of March, beginning of April of 2011, that's what was going through our minds. Is, who do we talk to? What kind of permission do we need? Are there permits required? And clearly we need to get in right away if we're going to gather this really important information that was never collected for Chernobyl. And Chernobyl, the first 5 years was under Soviet rule, and basically there was no biological data collected, at least none that we've been able to find. And so we knew we had to get into Fukushima as quick as we could to get this really important information. And so
is that a call to the State Department? Where do you begin?
We tried the State Department, we tried the embassy, tried the Japanese embassy. We tried, I had contacts at the University of Nagasaki. My university is actually a sister institution to the University of Nagasaki. We've had a long-term relationship, but we ended up not being able to get any kind of straight answers. And so in the end, we just decided, okay, we're getting on an airplane, we're going. And so we got on an airplane, met in Tokyo, rented a car.
Okay, so what do you put in your suitcase before you go? What do you know you're going to take with you?
The lead underwear, of course, but we brought GPS. You got to have your GPS so you know where the heck you are.
Right.
You got to, we spent a lot of time trying to get some sort of map of the radioactivity, and so we had some sort of basic idea of where the contamination was highest. So we had these maps, we had our GPS, we had Geiger counters, so we could do our own measurements.
Now, how soon after the tsunami was this?
So we managed to get in to Japan July of 2011, and the event took place in March 11th, so almost exactly 10 years ago. And so we got in just a few months after the actual disaster, which was.
Now you land, and I mean, does the person who's looking at your luggage say, what the hell is all this? I mean,
well, they did, especially when we landed with about 300 pounds of lead bricks as well.
Right.
And we had to bring lead. We couldn't find any place to buy lead in Japan, so that we could take measurements of the radioactivity of the birds and the mice and the plants that we were interested in. But you have to have lead so you can shield your detector. And so we all carried suitcases filled with 60 pounds of lead bricks from the U.S. to Japan. I'd almost forgotten.
How many people are on the team?
To begin with, we had three of us, and then we had I guess 3 or 4 Japanese collaborators. Actually, a couple more in the end.
Okay, so you didn't go.
Sorry, but are there any women on your team? Women?
We did, yeah. We had a couple of Japanese postdoc scientists who were helping us out.
I'm just curious about the effects of the radiation on fertility, both for men and women, and like any long-term, I think there's probably studies done on that, correct? Or
yeah, so there's a huge concern for female fertility, the concern is actually mostly for pregnancy, for pregnant women. So the developing fetus is the most sensitive stage, and so women who are invited have to promise not to get pregnant while they're doing work if they're of reproductive age. In terms of genetic damage to gametes, males are probably more sensitive. The spermatogenesis is probably more sensitive to radiation than the eggs per se. But we see this in the birds, we see this in the mice, but it's the developing embryo or the developing fetus that is the most sensitive stage, and that's what needs to be protected.
So you start driving, there's 5 or 6 of you in the team, right? Now, does everybody, the Japanese researchers, do they speak English?
Yes, we had we needed people to interpret for us, and so to limited degrees, to varying degrees. It is interesting that most people in Japan do not speak English very well. It's not a common second language anymore. It used to be more so, but now it's much less. But the people that were helping us had actually several of them had actually been to the United States for further schooling, so they spoke good English.
You didn't speak Japanese in any way, right? Because is this your first time to Japan?
Konnichiwa. Yes, it was not my first time to Japan. I've been visiting Japan every 4 or 5 years as part of this exchange program between my university and Nagasaki University. So I did have some contacts in place.
So you start driving. Now, how soon after you start driving do you see the effects of the tsunami? You must have seen them way before you got there, yeah?
So the effects of tsunami and the earthquake and the tsunami were everywhere. And, there was just a massive earthquake. So Tokyo, showed effects of the earthquake in particular. And then, but as soon as you get to Fukushima, the Fukushima area, there was basically no way to travel along the coastal zone. The coastal zone was a complete disaster. We did get special permission to come down from the north side, and basically it was a rubble field. It was everything was demolished.
Were you able to drive your car through it, or were you just literally, it was a disaster, you just had to carry everything in?
So no, they'd cleared the roads because they were actually having to bulldoze all of this material. They were still going through the material looking for bodies. This was there were upwards of 20,000 people who lost their lives as a result of the tsunami, and so it was a very dangerous place to be, actually.
Now, do you remember when you first saw the reactor? Did you get close enough to see the reactor?
So the first year that we got there, we could not get close enough to see the reactor, and it was that was totally off limits. It took us to the second year, 2012, when we actually solicited the help of a local fixer and television promoter who helped us get the permits that we needed to visit these different areas. And at that point, we actually drove right up to the reactor site and had a good close look.
Now, how long did you stay there?
For most of these visits, we go for 10 days to 2 weeks.
But when you're near the reactor, is it like, okay, let's get in, let's get out? Like, how long do you actually stay that close? Because that must be the center of the radiation, yeah?
So as it turns out, it's not. And although if you get right to the reactor, then yes, it's an issue. But in the area immediately surrounding the reactor, it was not the most radioactive areas. The most radioactive areas were actually at higher elevation. So there was a steam cloud of radioactivity that drifted towards the mainland, and it hit the mountaintops. And that's where the radioactivity is highest in Japan.
Now, do you set traps to catch the mice and the birds? Like, what do you have to do to be able to study them?
Not easy. For the rodents, we set traps. We put baited traps out and live traps, and we set them out and then go back the next day and see what we've got. For the birds, we have to string nets and so-called mist nets that they're like a fishing net, and they catch the birds. For a lot of the work, though, for a lot of the bird and the insect work, we don't actually have to catch them. We just have to see them, and so we can actually count them and identify them from a distance with binoculars, and so we can get a good idea of how many there are in different places that way.
Now, in an area like that, you don't know what the baseline was before. So are you just the first year, are you just setting a baseline? Are you going to another area to try and understand what it is relative to this area?
So that's a really good question. And it sort of gets at the essence of a relatively novel approach that we had to take in order to address that issue. What do you do when you really don't know what was there before? And so the only way you can do this rigorously is to sample the living heck out of the whole area, not just the area, the focal area of interest where it's really radioactive, but all of the surrounding areas as well. And by doing that, you can get an idea of what the effects of the local terrain are, the local vegetation, the water, and if you put all of that together. And so if you look at 400 or 500 different locations and keep track of not just the radiation, but everything else, you can use a statistical model to infer what should be at a given place. And if there are fewer organisms, is that related to radiation or is it just random chance? And so we took that approach in Chernobyl as well, and we applied it in Fukushima. But of course, with Fukushima now, we had a second place to compare our results from Chernobyl, and they were quite revealing in terms of radiation effects. Many parallels, many similarities.
Now, what were your overall takeaway from these two things in terms of the effects of radiation?
The sort of the main finding was that the numbers of organisms, the numbers of birds, the numbers of insects, the numbers of mammals is lower, or was lower, depending on where you are, immediately after the accident. And so there was very strong radioactive effects in both Chernobyl and in Fukushima. But and they were persistent for several years in Fukushima. The effects were stronger in Fukushima than in Chernobyl, but we think that's because we were looking at Fukushima, immediately after the accident, the first year, second year, third year, fourth year. Whereas in Chernobyl, we were only looking at these effects, 20 plus years after the accident, before we got there and started working seriously. So, but the main take-home message is that radioactivity is not good for these wild organisms. We've after getting at sort of the simple description of numbers of organisms and numbers of species, we also took a much closer look at genetic damage, fertility in the males in particular. For some species, we could look at how long they were living. We could look at whether or not males or females were more sensitive to the radiation, and it again, the basic bottom line is that where it's radioactive, the organisms are not doing that well.
We've built these reactors in a lot of different places, and from what I understand, the reactors that we build now are safer than the ones we built in the past. But what would you say to people who don't think that radioactivity is a big deal? I forget how many countries, I think it's maybe 17 countries have dealt with have atom bombs. What are your thoughts on all that? In Hiroshima, the fire bombs were as bad as the nuclear weapons, but of course there's no long-term effects from that, because as horrible as they were just fire bombs. So what are your thoughts?
Yeah, I've been trying to get at that specific issue, that exact issue. And my first thought was that all of this spent nuclear fuel, the millions of tons of spent nuclear fuel that we've created, was perhaps one of the, the largest threat to mankind. But I keep coming back to the fact that climate change is really, it's just so overwhelming. And sorry about that, but it really, I don't think it's on that same scale. Nuclear Armageddon, on the other hand, even a relatively limited nuclear exchange would be absolutely catastrophic. It could either accelerate or back up climate change in very negative ways. And so, yeah, I think my thoughts currently, as of today, are that nuclear Armageddon is still the biggest existential threat to the planet in terms of immediate consequences, followed by climate change, and then all of this spent fuel is certainly a major issue. There's going to be another Chernobyl or two in our future. You mentioned that there's most of the reactors are newer, but that's not true. Actually, most of the reactors out there are 20, 30, 40 years old now, and so they're potentially a hazard, a significant hazard.
The audience that's listening and watching this, Tim, I mean, what do you think? What is you've spent a life working on this stuff at your own risk, actually, I would say, to your own health. So hopefully you're strong and safe. But like, what do we do with this information? I mean, you're studying it as a scientist. NASA's looking at the work. I think you're doing a lot of really great things. But for the rest of us, just sitting here listening to this, what should we do with this information?
I think the main message I've been trying to get across is that there's so much more to learn, that we really don't know nearly enough about these the consequences of these kinds of contaminants, that we have ignored them because of our interest in nuclear energy and our interest in atomic bombs, and we've kind of pushed them aside, the hazards related to this, but it's something that we need to pay a lot more attention to. And so there should be greater interest in research in these areas. There should be 100 scientists working in Chernobyl, maybe or more, and instead of the half a dozen that are there doing biological research. That's my main message. But we just need to know so much more.
Tim, this has been incredible. Thank you very, very much for sharing all this information with us, and thank you for doing this work you're doing. It's super important.
Well, thank you very much. Always happy to chat about it.